Hello, everyone, and thank you for attending today's webinar, AI First, Leading from Research to Proof of Concepts. This webinar is brought to you by Qualcomm and is a continuation of our webinar series on AI. My name is Pat Lawler. I'm a Director in Technical Marketing at Qualcomm Technologies, and I'll be the moderator today. Before we get started, I'd like to go over a few housekeeping items. At the bottom of your screen are multiple application widgets you can use, including a widget to download today's presentation. All the widgets are resizable and movable. The slides will advance automatically throughout the event. At this time, we recommend you disable your computer's pop-up blockers. This will allow the slides to advance automatically. You can participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A widget, then click the Submit button. We'll answer questions after the presentation. Also, if you're experiencing any technical problems, please type your issue into the Q&A widget, and we'll be glad to offer assistance. I would like to now introduce our presenter for today. Zhilei Hao is a Vice President of Engineering at Qualcomm Technologies and the head of Qualcomm AI Research. Zhilei, please take it away.
Thank you, Pat, for the kind introduction. Thank you, everyone, for joining this webinar from Qualcomm AI Research. Qualcomm has a rich history of foundational research that have led to breakthrough innovations. It is also in our DNA to prototype that research to make sure it is deployable and scalable across real-world conditions. So today, I will talk about our AI First, both our novel AI research and our full-stack R&D work that has enabled first-ever proof of concept on real devices, such as smartphones. Today's agenda will cover the importance of full-stack research, a broad spectrum of AI First by Qualcomm AI Research in terms of both research and proof concepts, and also our future AI research direction and an exciting potentially next wave of AI First. We'll try to give you insights and intuition behind our research and inspire you to go further. At Qualcomm AI Research, we focus on advancing AI to make core capabilities such as perception, reasoning, and action truly ubiquitous across devices and industries. From an R&D point of view, we are developing the common platform that is foundational to scale AI across the industry. These platform innovations are common and essential to the AI problem that we are facing on a daily basis, which include power efficiency, which are the techniques to allow efficient on-device compute that's achieve power and area efficiency, and on-device learning, which are their machine learning technology to allow adaptation of the models to the user behavior and the preference, while preserving the data privacy. And efficient learning, which is ability to train with a little or no data annotation, and also to handle the model robustness and a generalization over adversarial samples. We are primarily focused on bringing AI to mobile, XR, automotive, cloud, and IoT, but the technology that we develop are essential and fundamental, and it can be utilized for other verticals and markets. At Qualcomm AI Research, we cover the entire spectrum of AI research and development, which is very exciting. We categorize our research into 3 areas, although there can be overlap. Fundamental research looks the furthest out into the future and is generally more foundational. Examples include everything from equivariant CNN, which is in the slide we're listing the GCNN, to self-supervised learning, to quantum AI. Platform research is a research that generally applies to improve the AI models across the board, such as quantization, compression, model architecture search. This research can then fold into platform tools that allow AI to run efficiently on hardware. And applied research is where we apply AI research to specific use cases, like a voice UI and a visual quality improvement. We also have exciting research topics overlapping among these areas. For example, graph and kernel optimization will conduct reinforcement learning research towards software platform optimization. Energy efficient perception will come up with innovative computer vision techniques with a broad platform impacts. And the video compression would invent advanced generated models for video codec use cases. In today's talk, I will focus on a few research topics across these research areas. All right, at Qualcomm, we are strong believers that having a vision and investing early in R&D. It often involves taking a holistic system approach where we set out to solve the big and challenging problems. We are known for doing this in wireless, but the same culture of innovation is present at Qualcomm AI Research, where we not only do fundamental research, but also full-stack AI R&D to connect the dots for business impact. So when we talk about full-stack research, we often have three focus. The first is model, hardware, and software innovation across each layer to accelerate AI applications. Imagine, essentially think about the slides, invention, model quantization, optimization, and a software compilation. And then the second focus would be early R&D and technology inventions essential to the leading ecosystem forward, such as we develop a proof of concept and providing the application for a stable and intuitive demonstration. The last would be transfer tech to the commercial teams and influence future research with the learnings from a deployment. This is essentially pointing towards ecosystem collaboration and bring towards a rapid commercialization at scale. All right, our purposeful innovation has led to many of the AI firsts. In this slide, we have listed 8 areas for innovation highlights. These are the first, both in terms of novel research and improved concepts of running on the target devices with full stack optimizations. So for all the highlights, we can roughly divide them into the 3 categories that we mentioned earlier. So from a platform research perspective, we have model quantization, we have on-device learning, we have a federal learning. Essentially on these topics, we have a focus on use case enablement and also to providing toolkits to the customers. The second category would be applied research. In this category, you think about segmentation, think about compression, super resolution. This will demonstrate our leadership in a mobile efficient computer vision. Then AI for wireless is to further promote and demonstrate our technology leadership towards a wireless industry. So, and also the last category, fundamental research, we listed the topic of the equivariant CNN. Our Qualcomm researchers have been pioneers for the rotational equivariance, which is a very important property for the neural networks to achieve robustness performance. And our researchers scored a best paper at iClear 2018. Due to the time limitation, we'll only cover 5 topics in this talk. All right. Now, the first topic that we're going to talk about is related to power efficient AI. Now, although AI is bringing tremendous new capabilities, it comes at a fast increasing energy consumption cost. The graph shows how the number of weight parameters is growing quickly and is loosely corresponding to the complexity and energy consumption of these networks. At our current trajectory, a neural network in 2025 will have 100 trillion weight parameters, which is similar to the capacity of the human brain, or at least in terms of number of synapses in the brain. So taking inspiration from human biology, the energy efficiency of a brain is about 100,000 times better than the current hardware. So we know there are exciting opportunities to do better than the current design. So where do we start to tackle this exciting opportunity in the power efficient AI? The answer is quantization research. So quantization reduces the precision of the weight parameters and activation computation. So then benefits, right? Again, going back to the power efficiency. So let's looking at the diagram on the right of the slide. And most of the time, models are trained and inferenced in the 32-bit floating point. So, but imagine if you can reduce the 32-bit down to 16 or 8 or 4-bit integers. And essentially what you can achieve is up to 4, 16, or 64x increase in the performance per watt from a saving in memory and a compute. So then, what is the magic here? What is the challenge, right, to achieve such, benefits? It boils down really two fronts. On one side is by reducing all the bit widths, you can still maintain high accuracy. And the second is about the automated quantization process and make it easy for the practitioners. So we have developed the 2 tracks of method to address these challenges. They include post-training methods and a training-based method. And often we also calling quantization-aware training. So from the convenience of the use perspective, in this talk, we'll primarily focus on the first track. At Qualcomm AI Research, we are pushing the limits of what is possible with quantization. And we have invented the best techniques for fast deployment of 8-bit quantization. Again, no training is required. I will discuss 3 methods that we have recently developed and published at the top AI conferences. You can see the bottom at ICCV, at ICML, and MLP. So for the data-free quantization, we have created an automated method that addresses bias and imbalance in the weight ranges. It requires no training and is data-free. And it allows us to achieve 8-bit quantization with very little loss in accuracy. And Adaround actually questions the common method of rounding to the nearest value. And it creates an automated method for finding the best rounding practice. It builds from a data-free quantization methods, and it requires no training and only minimal unlabeled data for optimization. It allows us to achieve 4-bit weight quantization without losing much of accuracy. And Transformer is an extremely popular model lately, and the quantization of Transformer model is also very important. So our researchers have demonstrated effectiveness of the earlier techniques and have created new per-embedding quantization for Transformer models. And again, it requires no training and a very limited data, resulting in the SOTA, state-of-the-art 8-bit transformers. We are very excited to see this amazing progress in quantization. All right, I'm also excited to see the speed at which researchers are moving to product or being open source. Our leading quantization research is being quickly commercialized and shared with the community through papers or open sourcing. We are truly driving the industry towards integer inference and a power-efficient AI. And for example, data-free quantization. We see the top left corner, the paper we published, ICCV, is already in a Qualcomm Neural Processing SDK and a Qualcomm AI Model Efficiency Toolkit, also known as AIbased. So we will recommend, please do join our open source project, taking advantage of our state-of-the-art model efficiency techniques and are contributing to make them better. AImid actually provides state-of-the-art quantization, compression, and techniques, and AImid Model Zoo provides accurate pre-training 8-bit quantization models. By creating these GitHub projects and make it easy for developer to use them, we hope to accelerate the movement to the fixed point quantized model for the whole industry. All right, now let's move to the next topic, on-device learning. AI is enhancing our lives and is being used all around us in many everyday tasks. It is providing entertainment. For example, if you think about smartphones, sports, TV, and video games. and it's enhancing collaborations. The webinar or video conferencing as we do now, extended reality, applications, and also AI is a transforming industry. Think about autonomous vehicles, smart factories, smart cities, smart medicines, and smart inspection. So need for intelligent and a personalized experience powered by AI is ever growing. And our devices are producing more and more data and could help improve our AI experiences. Then a big question is, how do we maintain privacy and dealing with all the data from edge devices? And first let's reiterate some very important benefits from on-device learning. The first would be continuous learning. The model can get smarter and adapt to the user behavior and the preference over time. And personalization, right, is about adaptation, particular from the human and the personal behavior perspective. And the data privacy, this is about making the on-device learning different from the cloud learning. And with on-device learning, the data never leaves your device. And scale, which is simply too much data to sending all in the cloud. Think about billions or even tens of billions of devices in the world. So on the right-hand side of the slide, we illustrate with additional learning after deployment, and especially on-device learning are important. The test data can differ from the training data, primarily due to the distribution shift, and it may even changing continuously. Actually, one of the very good examples is, imagine in a voice UI scenario, if you want Alexa or Google system to recognize your voice, right, in terms of what you speak and who you are. And then you realize actually the pitch or the tone of the voice actually changing as the seasons moves on, which is different from season to season. So then on-device learning can essentially help to improve and maintain accuracy as the season progresses. And while the original pre-trained model can now generalizing across the season boundaries. As we have conducted exciting research on device learning, taking even a step further, we can take the learning from on-device learning to a new level and apply them to a global model. And that is aggregate the model weight updates across multiple users at a centralized server to globally improve the model performance from a more diverse data. This will allow the global model to improve over time and stay up to date with the changing dynamics and the new data incoming. In addition, privacy is still preserved by conducting the model weights update while leaving the data staying on the devices. Well, we have many kind of technical terms on the slide, so let's stay back to explain a few terms, just make sure it's easier to comprehend the innovation from our researchers. So first of all, privacy is all about protecting individual information from a public disclosure. Then people are going to ask, well, what is the differential privacy then? The intuition boils down to participation of one additional individual should not change in the outcome. Or a little more precisely, for two different data sets, if they're only differing one person or one data sample's value, the outcome in the probability sense should be very similar. So in machine learning, differential privacy is usually achieved by introducing randomness in the gradients during the backpropagation. So then people are going to say, hey, privacy and a model update compression, this sounds like a very different thing, right? However, our researchers have identified they are really representing only two sides of the same coin. So regarding the model update compression, to reduce communication overhead, the model update compression decreases the message size and necessarily carries less information. And to preserve privacy, and a differentially private model update contains also less information about the local data. So now by taking advantage of this deep insight, our researchers are introducing a unified approach to essentially use a differential pricing method to enable high compression for a drastic reduction in the communications. So as you can see for the graph for the task about the next character prediction, on the x-axis, we denote it as a GB communicated. This is essentially representing the amount of the data communicated during the model update. And if we're looking on a y-axis, that will be representing the accuracy achieved by the global model. So, astonishingly, our method reduced communication costs by over 300x. This is just amazing. All right. Now let's look at from the proof of concept point of view, how do we contributing and transform the industry? So we introduced a federal learning framework for running on a Snapdragon-powered platforms. The framework is a scalable and a customizable software library that provides a TensorFlow and a PyTorch based training workflow for the mobile devices. Unlike the existing federal learning libraries that are mostly designed for research purposes, our framework providing a seamless workflow from a simulation-based approach to on-device deployment with a very minimal changes. Our software framework consists of 3 key pieces, as we illustrate in the diagram. Towards the left, a PyTorch-based library that is used for deploying the FL training setup and interacting with the training workflow. And in the middle, we have a Linux server software that can run as a coordinator for deployment in the cloud. And the last to the right, we have the C++ application that uses a libtorch or TensorFlow C++ library to run the training on Android or Linux to augment the scale of the training. So in between, the communication between all the nodes here take place using protocol buffer and gRPC software library. So at the most recent Europe's conference, which is a leading AI conference, we have to showcase our federal learning framework for mobile devices, which is the first such a framework being demonstrated. The demo showcases the use of our federal learning framework with 5,000 workers to train a voice user verification model on a commercial mobile devices that can discriminate the target user from an imposter. This framework can be readily applied to many use cases and application on the mobile platforms. So very exciting about upcoming exciting opportunity. All right, now let's look at a very important application, data compression. So the demand for improved data compression is growing as the scale of the videos being created and consumed is just massive. A few data points. Close to 1 million minutes of the video crossing the internet being transmitted per second. And online videos is approaching 82% of all consumer internet traffic. And also US adults alone spend about on average 76 minutes each day watching the video and digital devices. For voice specifically, there was about 15 billion minutes of the talking per day on the WhatsApp calls. It just lots of data from both speech and a voice point of view. So then the question is, why would we want to using the AI-based compression techniques, also known as a codec, rather than a conventional codec? So in this diagram, we're listing a few key benefits. AI-based compression can offer a better rate distortion trade-off, meaning that it can provide the same level of visual quality with less bits. And also it can be trained in a way specialized to a specific data distribution. And no special purpose hardware required other than AI accelerator, which is readily available essentially all the mobile platform today. And it's also easy to upgrade, standardize, and deploy new codecs. And also it can generate the visual details not in the bitstream and optimize for the advanced perceptual quality metrics. And further, providing semantics awareness for the human visual perception. So neural video codec research is showing a great promise. I will highlight one of our novel techniques, instance-adaptive compression. So there are scenarios that people can imagine where the types of video streams that I expect to be seen are quite narrow. In case such as this, it is possible to overfit the AI codec such that the encoded bit streams is even more compressed. For example, when someone downloads a popular movie, right? The AI codec actually can overfit a model on the scenes of this movie to specialize to a given data distribution. And in this diagram, actually, we illustrate how to overfit a model on one video instance and encoding the weight deltas in a bit stream. So now looking on the diagram here, if you're looking at the bottom right, and this is just representing a very typical neural codec workflow without the instance adaptation. So now, as we augment the approach with the instance adaptation, so what we do right here is as we running the video stream through the neural codec itself, we also adapt the models on the background. And with all the model updates and the weight deltas also being sent over from the transmitter to the receiver. So for this approach to make sense and leading to an overall smaller bit stream, and the weight deltas and the encoded bit stream from the overfit model must be less than bit stream created by the baseline model itself. But luckily, I think our research has been pointing to the confirmation for such approach, which is a very exciting method. So again, coming back to the proof of concept perspective. So here's a setup of our neural interframe video decoder demo. We take essentially HD video as input and generate a compressed video stream by running the encoder network and entropy encoding offline. The compressed bit stream is processed by the parallel entropy decoding and a decoder network running on a mobile device powered by the Snapdragon mobile platform. Specifically, the parallel entropy decoding runs on a CPU cores, and the decoder network is accelerated on a 7th generation Qualcomm AI engine. The result is then the first neural interframe decoding algorithm that runs at 30 frames per second on a mobile device, which is the first ever such thing running everything in neural codec on a mobile device, which is very exciting. We were the first to demonstrate in this demos for the intra-frame scenario at the CVPR 2021, and for the interframe, essentially the full video codec on the decoder side at the NeurIPS 2021. All right. Now let's turn to our next topic, super resolution. Super resolution takes a low resolution image and a video and it creates a high resolution image video. And this capability is very useful across many applications. AI-based super resolution offers improved visual quality over traditional methods. And up until now, on-device deployment that meets the real-time performance, latency, and power requirements at a high resolutions has not been feasible before. And our full-stack optimization have made state-of-the-art single-image super resolution over video stream possible on a mobile device. We did several full-stack optimizations here, include model architecture optimization, model quantization, and a hardware optimization. More specifically, on a customer architecture side, we have invented the quantization robust model architecture using optimized residual connections. And on the quantization side, we're leveraging the quantization research, as we mentioned in previous slides, and also applied through AImid toolkits we have come up. And further, on a hardware optimized perspective, we efficiently utilizing our AI acceleration of our Qualcomm HTP processor via a technique called channel-wise input tiling. So what is this tiling technique? At a very high level, you can think about if you have a huge input image at a high resolution, right? You can split the input image into n patches. And then you can stack the patches on the channel axis and then replace the convolution with a group convolution. With such, we can greatly speed up the inference for the high resolution, super resolution techniques. Okay? So our super resolution implementation provides a higher performance at a lower latency and power while maintaining accuracy. So looking at the graph here, you can see our models versus existing solutions. The y-axis showing PSNR or accuracy, which higher is better. The x-axis shows the relative latency where lower is better. So we want to be in the up left corner of the graph. So the size of the dots represent the relative power where a smaller dot is better too. So all the red dots, they are pointing towards all the public models in the literature, but we have done optimization based on our hardware behavior. The blue dots are pointing towards our research proprietary models with a customized model architecture. So it is clear to see that our solution not only has the highest PSNR, but also the lowest relative latency and power. So with full stack optimization, we demonstrated the first 4K super resolution, which can run at 100+ frames per second on our mobile platform. Looking at a picture between low resolution with a super resolution picture, we can see the super resolution images essentially is much more sharp and crisp, which demonstrate the benefits from AI power. All right, now let's looking at AI for wireless and RF sensing. Interestingly, RF sensing and neural rendering offers synergistic capabilities. It is analogous to the compelling capabilities of computer vision versus computer graphics. So we have seen very good, kind of contrast between the two. So now let me explain. Now let's looking at the left diagram. Computer vision actually take an image and describe the real world. Think about objects, think about the structure, think about the human, think about the positioning of each of the object. And a computer graphics is an inverse process, which takes a description of the visual world and create a realistic image. Similarly, the neural RF sensing can take an image of the channel state information, describing the wireless conditions, and it describes the radio propagation environment. So in a sense, you can think about channel state information is like a 3D pixel with a radio measurement for each of the pixel. And then again, we also have an inverse process on the wireless side, where you can come up with a neural channel render, which take the environment as an input and then generate a spatially consistent channel state information. So these insights are very powerful, as it would allow us to bring advanced machine learning practice from a computer vision world to the wireless world. We are very excited for the opportunity, and given our leadership in both mobile computer vision and the wireless, we're very excited we can further invention to this new frontier. So again, now looking at also very, very important concept that we are driving in the wireless world. The neural networks, and as we know, can also be used to augment traditional algorithms, thereby achieving increasingly accuracy and also model generalization. We call this technique specifically as a neural augmentation. So core idea here is for a given domain problem, one can utilizing the favorite classic algorithm while augmented with the neural network architecture. This is a powerful combination would incorporate centuries of scientific knowledge and use of the power of deep learning to identify the subtle patterns, which may be too complex to model explicitly. So this approach would often result in very compact neural net model size, high data efficiency while training, and achieve robust performance for model generalization. So we are the pioneer to apply the neural augmentation to wireless communications. So expertise in both wireless and machine learning is what allows us to see this synergy and using neural networks for the right problems. So two examples that we are demonstrating here are hybrid network Kalman filtering and generative channel modeling. So regarding the first example, I'm assuming most of you are fairly familiar with Kalman filter. So what we do here essentially is keep the Kalman filter, which essentially the formulation and equation as how do you predict the next coefficient, the next state of the underneath model intact. But we're using a recurrent network to update the coefficients of the Kalman filter. And we have observed substantial performance benefits, for example, for the wireless problems where the high Doppler channel conditions. And the second such problem we are looking into is called generative channel modeling. So what we do is we keep the linearity of the model from the Maxwell equations, right? This is a very classical representation. So while we're using the generative model to learn the distribution of the channel H itself, then we have observed a very compute efficient way to generate such channel methods as compared to the conventional methods. So this is very exciting progress we have made in the field. So now let's come into the proof of concept perspective of AI for wireless and RF sensing. So here we showcased the first weekly supervised indoor positioning in our indoor Wi-Fi setting at the Mobile World Congress 2021. So our new machine learning based methods working on large floor plans and achieve high accuracy with only weekly label training data. So this is a very exciting thing and also we believe have a demonstrating video. We have a link on the bottom. You guys can point it towards offline. We'll be very happy to take further inputs. All right, now let's looking at the potentially future exciting AI firsts coming from Qualcomm. Again, we listed a few exciting areas here. The first will be the machine learning for discrete optimization. This essentially are for the domain where we looking at the decision-making problems, where the design space exploded. So then people think about, hey, solvers, what does solvers mean, right? But if people are from a computer science world, probably should be familiar with many times when you think about non-convex problems, when you think about mixed integer programming, think about SDP, semi-definite programming. I think these all largely falling under this category, where we feel machine learning kind of providing a lot of new exciting problems for this space. And then condition compute, as we want to further improve the training and inference efficiency on various techniques for dynamic computation to think about, for example, frame exit, think about the mixture experts, think about multitasking, multimodality, multi-device. This is a new compute pair paradigm. We felt it's kind of providing further benefits from a power efficiency point of view. And on-device learning, we have largely demonstrated a lot of cool use cases from an audio and a voice UI point of view. However, we feel the next week probably coming down to computer vision. This is also very exciting field. So then AI cloud platform, where we think about the turnkey solutions to further democratize the AI use with a very low code or local use for people can using a lot of tools in a very user-friendly manner. And then coming to the wireless AI, we see there's a great opportunity. We can further combine sensing and communication together. We can using sensor capability to further augment and facilitate communication. and vice versa. And we feel this is going to be a very important pillar or very important technology as we're moving from 5G into 6G. And also 3D AI. This is, in terms of how do you think about efficient total scene capture and a novel view synthesis for a mobile platform. I think we feel Qualcomm going to be leading this area in a very exciting way. And then AI for the hardware design. Again, from a microarchitecture co-design or from an SoC placement point of view, we understand there's ongoing work, including us. We look into space, but we have to emphasize in how to design the work in a very data-efficient way. We feel we have our insight. We're going to be providing further benefits to the industry. The final topic, not the last topic, is going to be the neural reasoning. We believe with interactive learning and embodied AI, we can move beyond perception to reasoning with autoregressive language model, and we can further bring AI to new compute paradigm. All right, to conclude, I would like to summarize by saying that we are conducting the leading research to enable edge AI. And due to our full stack AI research, we are first to demonstrate proof of concepts on mobile devices and also edge devices. And we are solving system and feasibility challenges to move from a research to commercialization. All right, thank you. I'll be happy to working with the Pat, moving into the Q&A session.
Great, thank you, Jilei, for the great presentation. As a reminder, if you have questions related to the material, please submit them using the Q&A widget. We've already received quite a bit, so let's get to the questions. So first question, Jilei. For full stack research, how is Qualcomm AI Research different from other companies?
Yeah, Pat, this is a great question. I will address the question largely from the two fronts. First of all, I think we have a great strength in the power efficient AI and on-device learning, as we have emphasized throughout the presentation for edge and device applications. So our insight into power efficiency in terms of the hardware accelerated behavior will truly allow us from a full stack point of view, looking at from a model research to software compilation to the hardware innovation, how we can looking at interdiscipline invention and collaboration altogether. And the second, we should say, probably speaking, Snapdragon mobile platform is arguably the best mobile device ecosystem. So that allows Qualcomm to have a great influence and also have the collaboration benefits or advantage in the mobile AI and the edge AI space. We can conduct many collaboration and influence the industry. All right, thank you, Pat.
Great, next question. We actually received a few about neural codecs. But the first one would be, for neural codecs, when do you expect to get on par with traditional hardware codecs in terms of frame rate and resolution? Is there a clear path?
I would say in the short, first of all, I should say our team is a research team, and we are not looking at it from a product roadmap point of view. So what I'm commenting here is only focus on research, not the product perspective. So from that sense, I would say, generally speaking, I'm fairly optimistic in terms of all the research we are doing here and what's going to leading up to. Essentially coming back, right? If we can taking this a full stack, research point of view, I think there's a few fronts we can continue to pushing the frontier. And on one side, with the continuous enhancement in the model learning representation, which is more from a system model research perspective, we felt there's a lot of new mileage we can still further develop. And also we know the process node itself will continue to advance. And also, and coming back to the other more interdisciplinary research, we're working with the product side, looking at from a graph, from a kernel, even think of a multi-core, multi-device, software compilation, we feel there's a further, potential, a lot of potential to improve the efficiency. So we believe the combination of all the different topics I mentioned, again, looping back to the, full stack research point of view, in terms of going from where we today on device on HD into, let's say, potentially in the 4K in the future, we felt there's definitely a clear path forward. Thank you. Yeah.
Great, and I'll finish up with a few other neural codec questions. This one should be pretty quick. Is the bit stream from a neural codec standard compliant?
Let's be a little subtle here. I think, generally speaking, you have a different ways you can treat the AI codec. Okay, the method that we are demonstrating here is taking more end-to-end approach. We replace the conventional codec completely by AI codec. So in that sense, this AI codec is not backward compatible. Or the other flavor people can do, which, for example, in JVET MPAC context, people have looking at a more augmented approach, which is augment the existing codec with the new machine learning approach at a component level. But I would say either way, I think, essentially coming down to whenever either it's a conventional codec or machine learning based approach, if you want to having interoperability from a different device or different vendor point of view, you have to go through the standardized process itself. Okay.
Makes sense. And I'll just quickly answer this one. A question about whether it's available on 865 based codec. And again, you answered it's research, so it's not a product. Moving on to the next question. With all the full stack optimizations that you do, is there any insight on which optimizations offer the best benefits if you could only do one?
This is a great question. Maybe let me, pointing back to the slide, which I can re-emphasize here. Can you guys see this slide?
Yes.
So yeah, my short answer will come back to quantization, because I do feel many times how the people approaching the model development, the model many times are over parameterized. So in that sense, there's a lot of juice inside the model itself. By a holistic view of how you're approaching quantization, how would you design a quantization-aware model architecture? We feel this is probably the most low-hanging fruit, from Qualcomm and from industry people should pay attention. And Qualcomm is building the best fixed low-bit inference AI accelerator for the mobile platform. So we felt this is a space we can work together and make a lot of impact and bring a lot of application to the best user experience possible. Okay.
Great. Now some questions I'm seeing are about on-device learning and federated learning. Why is it important to train models on edge devices when they can be trained in the cloud?
Okay, this is a good point. Let me pushing this slides forward. I would say there's a couple benefits immediately coming to my mind. Actually, maybe this is even better slides we can use. So, from an on-device learning perspective, I think there's a few things. First, I will say the most, right? For many people, I wouldn't say everyone. For many people, for many of the vendors, for many applications, data privacy is essential. So in that sense, keep the data local is very important. And the second, if you think about scale, because if you think about the human mobile phone, think about the AR devices, think about the IoT devices, it can be billion or even tens of billion devices out there. The scale itself is massive. So if you can have a distributed way, letting the training largely happen on the device end without transport all the data back to the central cloud, you can achieve the training with a much higher efficiency at a scale. And last but not the least, right? Because as I mentioned earlier, the voice UI use case I was given here, people's voice and pitch is changing over seasons. So how would you be able to, using continuous learning and to learning, adapting the voice UI model on a device, allow adapting to my, behavior over the different seasons? This is enormous personalized benefits. Allow me to, the AI model to better serving my use. So with all that, we feel there's a compelling benefits for on-device learning, either from purely on-device adaptation point of view, or you think about you can taking the crowdsourcing type of view to aggregate the model updates. I think, but depend on the use, depend on the KPI or performance use. I think people can using various different forms of techniques. All right, thanks, Pat.
Great, thanks, Julie. There was interest when you talked about the federated learning research and the framework that was created. So there was a question, and I don't think it's released yet, but maybe you can provide guidance. Where can I find federated learning framework for experimentation purposes?
Yeah, we basically talk about this framework. This is a great question. By the way, we are very happy to hear this feedback, because the whole purpose of us to develop this platform is at a certain point we would like to release to the, essentially the ecosystem of community, allow the people to benefit and develop the applications on top. I would say, at this point, we are very encouraging with the progress we made. We are actually is working with the different teams internal, looking at the best way to, release this framework in some form. So stay tuned. I'm sure we'll make some announcement fairly soon. Thank you.
Thanks. Next question. Researchers seem to be asking this. What advice can you give researchers on how to take more into account developing models that are more easily deployable on a mobile device?
I think, yeah, this is a great question. I think in a most simple form, I would say probably coming down to this. Let me point you to this slide. So I think that the best way for people to think is, think about it as AImET, which is called an AI Model Efficiency Toolkits. We have, essentially open sourced in a GitHub. And this has incorporated many different techniques that we have, accumulated on an advanced AI research frontier. Many papers where the content we have essentially all fold into this toolkits. So I think this toolkit going to providing a tremendous amount of utility for people to think about how to take advantage, how to make it's easier for you to deploy your model for a mobile platform. I would strongly recommend folks to pay attention to AImET and AImET Model Zoo. Thank you. Yeah.
Great, thanks, Julie. Next question, which potential AI firsts are you most optimistic or excited about?
This is a very difficult question. Let me make an attempt here. All right, here are all the examples. We have a kind of listing on here. I have to say I'm a little struggling here, but let me coming from a really forward-looking point of view. I think the topic probably exciting me the most, out on the bottom right corner, the neural reasoning, because as together with embodied AI and interactive learning, right? Imagine, many people talk about metaverse. So if you think about metaverse and the physical world, right? They're like twins to each other. So there's a really fast progress where people have coming up with a photorealistic simulator, which is a mapping from the physical world into the digital space. So then imagine with that simulator become available. So it will make embody AI in large form. Think about an agent sitting inside the robot, right? In which can make the agent to interact with the the simulator in a very interactive way. But because this simulator is a photo, is a scene, is a physically realistic, so then a lot of our machine learning training actually conducting a simulator can be easily transferable and generalizable in the real field. So with this kind of embodied AI with interactive learning capability building in, and then we can basically allow us to move beyond perception into reasoning, while we can taking the form of the autoregressive language model as underneath grounding techniques. So now, if you connect all the dots, think about embodied AI, think about interactive learning, think about neural reasoning. We feel this is very exciting for the next 5-10 years for us to expanding the new horizon and helping expanding the AI capability in a very substantial way. So then, slightly, sort of a different angle when we talk about, what topic make me more optimistic? I would say all the topics going to make me optimistic. So I'm very excited for all the topic we're listing here. They're going to make a very substantial impact for Qualcomm, for the research community, and further to the industry. Yeah, thank you.
Thanks, Julie. And since you mentioned metaverse, I saw there was a question kind of related to XR. So how is Qualcomm AI research for edge and mobile devices going to help with on-device AR, VR, XR processing?
Again, I would say, generally speaking, topics are more into the AR and VR world. I think I'm sure, from a product management team or from the commercial side of the team, they will have a very strong message. I do see, for example, some of you probably noticed Qualcomm have made a few acquisitions in the VR and AR space, and accordingly with announcement. So that means that clearly this is a space that Qualcomm going to lead the pack and also make sure develop the ecosystem for this area. But one thing I want to emphasize, I think one of the strengths at Qualcomm, right, from a full stack point of view, not just for wireless, not just for AR, not just for AI, actually into AR. I think the full stack point of view to emphasizing on the low power perception and a low power AI capability and a low power XR capability from the whole system point of view, and that's going to be our strength, and that's how we're going to help in the whole ecosystem on a moving forward basis. Yeah.
Okay, thanks, Julie. We had several wireless kind of questions, and given your background, I thought you should give them a shot. How do you model the noise and interference in a wireless channel? Is there any article to read regarding the wireless channel?
This is a very interesting point. Think about it in a very funny way. I think when people talk about channel, right? If you think about H, let me using this jargon, let me make an interesting attempt. So when people think about channel in a narrow sense, this H itself actually is not the noise, is not interference. Because typically, if you think about Shannon equation, right, it's going to be Y equals to X times H plus N. That the additive noise, N itself is a more incorporating noise and let's say interference from an intra or inter-cell point of view. But the beauty about machine learning is just that we know in the real deployment scenario that the N, the term of the noise, added to the noise, which could be noise or additive with all the interference together, is very complex. And it's changing from a cell to cell, from a model to model. So then the beauty about machine learning is indeed, because it's very difficult to model, if we want to take advantage of the property of that N, the property itself in the statistical sense, actually can be learned by the machine learning. So that's why learning the end and the learning underneath the distribution end in return can help us better to understanding the H, better understanding eventually how to help us to extract in this particular the X. X essentially data sample eventually you want to recover. Yeah.
Great, thanks, Julie. We're at the top of the hour, so I think that will have to be our last question. Sorry for everyone that we couldn't get to your questions. So let me conclude here. So on behalf of the Qualcomm and our presenter, Julie, thank you for joining us today. The webinar will be available on demand, and I hope you have a great rest of your day. Goodbye.
All right. Thank you. Thank you, Pat. Thank you, everyone.